Hey folks, so today we'll talk about the artificial intelligence agents and the agent memory, because we all realize for sure that there are LLMs, they nice but not enough, and entire movement around the agents moving into some complex structures that actually use the LLMs or use the different kind of models, but they use it together with some completely different tools, patterns, and architectures. And we finding more and more papers that describe how to build these cognitive processes and the memory for the artificial intelligence agent. So we all agree that the agent should remember the facts. And the main question right now, how agents should remember, how agents should recall, how agent actually should process and store the information. And here we have the endless amount of papers, and practically every week we get more papers, and another stream actually it's the RAC and all other things, and somehow RAC, recall, and memory, they all connected with each other, because to get something you need to store something. It's obvious. And one big domain that I actually support is this more the human and biology stream. It's not a new thing, it's to be more bionic and all other things, that we copy something that nature creates. So we try to mimic the AI agent memory from the human memory, right? So we have this declarative part, we have the operational memory. In the declarative memory we have the episodic and semantic one and all other things. And if evolution actually create this type of structure, maybe it makes sense to mimic it. But the more I read about the cognitive psychology and about how the brain works, the more I realized, first of all, that on practice it doesn't know much. And I could read one concept and one theory, and in another book immediately I could get completely different definitions and completely different concepts. So we need to admit that we still don't know. We know a lot with the MRIs and all other things. We understand in which parts of the brain things gets activated for the different memory tasks and all of the things. We know that semantic memory and episodic memory is something real, and they exist and they decoupled. But again, it's quite hard, because if you focus on the semantic memory, for example, we know that we store the semantic facts like they abstract concepts that connect to each other, and the concepts that close to each other in a distance, they somehow stored together, right? And these concepts connected to each other, so they form something that we model as a knowledge graph, right? And another theory say that this more encyclopedic, more abstracted concepts doesn't make sense. And they say that we have these semantical concepts connected to our motion and skill system, and all of the things and concepts could be different based on the the situation and all of the things. So this create more dynamic, more rich semantic model. And when we get back to the 60s or 70s, we will discover that at that time people were thinking about the semantic memory as a hierarchical structure. But we throw away this concept because we could not fit everything to the hierarchy. But recent research say that semantic memory actually have the hierarchy. Yeah, so that we have a couple of 3 layers of the hierarchy even for same concept. And it's something like taxonomy, that if you're thinking about the chair, we know that it's a part of the furniture, and we have the concept of the chair, and then we have more concrete chairs, and all other things. And it's quite interesting that instead of the flat knowledge graph that we have something that operate with the same concept on the different level of the hierarchy, and here it's mean that rather our knowledge graph will be extremely complex, or we could encode this hierarchy to the property graph, or we maybe could operate with the different interconnected graphs to model this hierarchical part of the semantic memory. But it's more interesting that this semantic memory really persists and store the facts in different regions, depends if it's a live or it's not live object, and if this live object have the motion patterns, and even if the concept somehow connected to the motions and the operations, it will be stored and processed in completely different part of brains. And in the recall procedure of this motional thing, we will activate the part of brain that's responsible for this motion and the skills. And it's mean that the semantic memory itself, it's not isolated. But what's most important about the semantic and episodic memory, and we know that episodic memory recall over the time, fade over the time, that our memory process is the constructional process. So it means that we're not just getting the information, we just getting the pieces of information, and we craft the story every time. And it's mean that we have the ability to create some imaginary or possible scenarios based on it. So it's basic of our imagination, the planning and creativity, but together with this constructive process of the memory recall mean that we could have the false memories, or we could have the damage of the memories. And if we have some different difficulties in the brain and all other things, for example, we have the harmed hippocampus and all other things, we will not able to create these things. And another thing that the construction mean that we have slightly different story every time. So, and if we will get back to the semantic, in semantic it's more dynamic, it depends on the recall and reconstruction and constructive process. And even more interesting that another concept say that in a semantic memory we store something in a schema. So the schemas is some clusters of the conceptual knowledge that have some structures. So it's been something like subgraphs, right? And it's even more interesting that these schemas could be combined together in a sequence of the events, let's say, that represent the scripts. So now we have in a semantic memory the concept of the schemas, we have the concept of the script, we have the concept of episodic memory, and you see it's quite complex, and it's really complex thing that we don't know how it's fully work. And then it's a linked question that, you know, this memory recall was designed to support our brain and to really feed to our energy levels and our capabilities of our body. And if we build in something for the artificial intelligence, that maybe silicon doesn't have these limits, they doesn't have this problem, and they have completely different capacity for the space, they have the completely different capacity for the energy. Should we mimic something that we don't fully understand? Should we mimic these complex processes that our brain have? And as you could see, we have completely different concepts. And if we will take only the declarative part of the memory, and if we will take only the semantical piece of the memory, we will see that we have some simplifications that allow us to use knowledge graph effectively. But if we will add, for example, this concept of the schemas and the cluster of the knowledge, if we add the concept of the hierarchy, it already will be extremely complex, and this complexity forces us to use the metagraphs for the semantic memory. And then it's a legit question. Should we go this path and be more bionic, or should we maybe build some superhuman memory that, for example, do not use the constructive processes for the memory recall? Or should we do the opposite? Should we follow this and make this constructive process more robust that allows us to combine the different information and synthesize the new kind of knowledge? And it's an open questions actually, and I'm quite keen to talk about these questions, and I want to discover more. But I have a feeling that it's not just tasks for the artificial intelligence engineers, LLM developers, and maybe ontologists, because it's involved more and more the domain experts that know how the cognitive processes of the human brains work. And maybe we need to think about the cognitive processes of non-human beings, because actually the artificial intelligence is not a human, and maybe it's not mimicking the human flow. So that's all quite interesting, and I'm keen to talk with you. Next week I will be on the connected data and learn a bit more about the knowledge graphs for sure, but I still open to talk about the memory in this connection of the graph topic. So keen to see you next, and stay connected. Choose.